So this section is a little introduction about slope fields. I've had a couple of them up on GeoGebra that you guys have been walking in the class. And the whole idea is that you'll be given a differential equation, so something that has x and y in it, or just possibly just y, or possibly x. And so this derivative measures the slope, and what you can do is draw little line segments based on the slope. And since you have the slope, it paints a picture of what the solution curve looks like. So this is the solution to this derivative. It's going to be a circle, or maybe an ellipse, okay, depending on the c value, the arbitrary constant. So what this is saying is that the solution to this differential equation, so the actual function, is a circle. Okay. The next example I have already drawn out some hyperbolas. Even though it looks pretty much the same as before as far as the solution, notice it's no longer negative. So this positive negatives play a huge role in what the solutions look like. So in this case, the constant is positive, and it leads to a hyperbola instead of a circle. Okay, so if it's something like that. I have two more examples to kind of talk about. This one looks like it's exponential growth, and notice this one only has y in the first derivative. And something I'm going to draw incorrectly just to show you is that if I try to draw something that's exponential growth, but I draw it incorrectly, so it looks something like that. Notice that it doesn't really fit the pattern of what the slope field is doing. Even though this line is exponential growth, it doesn't necessarily fit what the slope field is doing. So this is drawn incorrectly. So how it should be drawn is maybe a little flatter to begin with, and then something maybe like that. Another possible solution curve would maybe start this way and then go up like that. It could also be exponential decay, so it could maybe that it starts and goes somewhere like that. If it's a negative constant for exponential decay. And the last thing I'll talk about is solutions that we can't find. So for this differential equation, we won't be able to solve it using any of the techniques we know that we'll learn in this class. So even though we can't find the solution to this, the slope field does help us draw, or help us see what the solution curve looks like. So even though we can't draw this, or even though we can't solve it necessarily, we can see that the solution curve would kind of look something like this. Okay. If it's negative, maybe it looks something like this. Another possible solution would go somewhere like that. So we can kind of tell what the solution curve looks like without actually being able to find the solution. Okay, so that's kind of just an overview of what slope fields are and how they come into play with this chapter. If it's exponential decay, that's going to be on the negative side. Now, exponential growth should look more like that. Exponential decay will look something like this. So these are just solution curves that are passing through the points for the other one. Now, this isn't something that we're going to be able